Good morning, everybody, or good afternoon at least, where we are in Cape Town. My name is Mark New, and I'm based at the African Climate and Development Initiative at the University of Cape Town. It's my job just to briefly welcome you to this webinar where some of the authors from the Working Group 2 IPCC report are going to be presenting some of the insights that the report presents from an African and Southern African perspective. The webinar is going to follow the following format. I will be handing over to Bruce Hewitson, who will be our chairperson for the duration of the webinar. That will then be followed by two relatively in-depth presentations by one of the coordinating lead authors for the Africa chapter, Dr. Chris Trisos, and then from one of the lead authors from chapter 16 on key risks, Guy Midgley from Stellenbosch University. And then we will have short inputs from a number of other authors on the report, focusing on particular areas where they had responsibility for generating information in the report. And then that will be followed by a lengthy period of time for questions and answers from the audience. So I should just acknowledge firstly that this is a joint University of Cape Town and University of Stellenbosch webinar. So we're appreciative of both universities for providing us with the platform and opportunity to present some of the highlights from the report to the audience. So I'd like to hand over to Bruce Hewitson, who is not involved in Working Group 2 directly, but is one of the lead authors from Working Group 1 on the physical climate science basis. But Bruce has kindly agreed to act as our chairperson for this webinar. So over to you, Bruce.
Thanks, Mark. I'm going to try and keep everybody to time so we can maximize our conversation time later on. I just want to make some opening statements and just put some context around this. I think we're all aware of what's going on with Russia and Ukraine at the moment. We've been living with a pandemic for a few years. We daily experience a host of political and socioeconomic pressures at national and regional scales. And it's easy in this context to get diverted what is from probably the biggest long-term threat. For myself, I've been continuously in the IPCC now for 25 years in various roles. And if I was thinking back to this webinar, I'm thinking when I started in IPCC, the question was, how do we know this is real? We have to prove the case. And then we moved and evolved over various iterations of the assessment reports to politically fraught questions such as loss and damage, inequalities, and now to here's what we have to do and by when we have to do it and how we're going to try and do this. So while many of the underlying messages have persisted from the early days of the IPCC, one of the biggest changes in this report has been a move from Working Group 1 doing a handover of the physical science to Working Group 2 to instead Working Group 1 and Working Group 2 doing a handshake, a cross-fertilization between the two. And we see a fundamental change in the dynamic of the reports as a result. So Working Group 1 this time around had a lot of regional expressions in the chapters, even included some sections on ethics and issues like that. And Working Group 2 is much more integrated in with what the physical science messages are saying about the impacts of adaptation. So in this webinar, that's the framing for this. And we're going to present an Africa lens going in on this. And I'm going to hand over now to Guy to start us off. Guy is from the University of Stellenbosch. He was in the chapter on key risks. And Guy, you have 10 minutes.
I'm going to share my screen. I'm going to present results based on essentially chapter 16, which was on key risks across sectors and regions. And this chapter came up with a couple of really interesting new approaches and summarized a lot of new data. So, and it has several statements which are highly relevant to Africa in it. But I wanted to just open with the bottom line of the report. I meant to thank Mark and the organizers of ACDI. Sorry about that. Appreciate all the efforts that went into organizing this meeting. So you've got to read all the way to the bottom of this report to see this line here, which is line SPDM D5.3. And it says The cumulative scientific evidence is unequivocal. Okay, so any further delay in concerted anticipatory global action on adaptation and mitigation will miss a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all. Very high confidence. So that probably is one of the strongest statements ever to come out of IPCC Working Group 2. So let's start with what's new. Firstly, we've got a much larger evidence base, and we have improved attribution standards. In other words, people are tying impacts much more tightly to the observed changes in climate. We see results now at greater detail. We have more studies that have been conducted at a finer spatial resolution. And that also helps to improve our confidence. I think in our chapter and across Working Group 2, we're now using better synthetic methodologies, and especially with regard to the burning embers risk assessment, which I'm going to show you some of. This is an effort to use much more quantitative methods of assessing risk at different levels of global warming. We, in Chapter 16, used a new approach called representative key risks. These are risks that can be classified as severe. In other words, they're relevant to dangerous anthropogenic interference with the climate. For the first time, we included adaptation in assessing these key risks in a more quantitative way. We looked at overshoot scenarios, and we, in this report, have a far deeper analysis for the African region, which is largely entirely thanks to the Africa chapter, who've done an amazing job this time around. All right, let's look at, this report is replete with very detailed figures, but I want to put a few of them up because it shows you the granularity, the detail that we now have with regard to, in this case, ecosystems and biodiversity, which is an area on which I focused. And you can see here, if you look at the confidence in observed changes in ecosystem structure, range, species shifts in range, and changes in the timing or phenology of species responses. High risks are in dark blue, and then the confidence is in dark blue, and the level of confidence drops with the shading of those circles. And you can see that globally, our confidence is extremely high across across everything, but that there are some regional differences in the levels of confidence. And you can see that with respect to the Southern Hemisphere and with respect to Africa, we've still got a little bit of work to do. We're not way behind, but we need especially to work in areas of the Antarctic. And I saw Ria Olivia on the list of people attending. Ria, I think we can really add some sub-Antarctic work into this body of work quite productively. But certainly deserts, biodiversity hotspots, montane regions, and tropical forests, there's still a bit of work to be done. But Africa as a whole is not lagging far behind. You can see there Africa at the top. So as I said, with respect to the Antarctic, to biodiversity hotspots, montane regions, the levels of confidence are much lower for the Southern Hemisphere. But for Africa as a whole, we're not doing terribly badly. Okay. Let me move forward from there. So let's look at two clips straight out of the report, risks in the near term and risks in the medium to long term. And we can see here that our conclusions are that 1.5 degrees, reaching 1.5 degrees will cause unavoidable increases in multiple climate hazards and present multiple risks to ecosystems and humans. We have very high confidence in that. Of course, there are a lot of riders to how that risk will vary according to vulnerability, level of socioeconomic development, and ability to adapt. But certainly, 1.5 degrees is a level at which things really do start to take off. Because if you look at the mid to long-term risks, 2041 to 2100, we find that climate change will really lead to numerous risks to natural and human systems with high confidence. And this has been assessed for 127 key risks. So, as I say, we have a lot more evidence at at much greater resolution, spatial and in terms of response. One of the bottom line messages from Chapter 16 ends up with these what are called reasons for concern. These are fairly well known by now, the so-called burning embers diagram. And in our report, you can see that these are expressed as a range going from moderate to very high risk, with levels of confidence now inserted at the transitions between these risks. These are done using expert opinion in a very quantitative methodology. But what's useful to see is the projections of global warming and the trends of global warming, including what are these so-called overshoot scenarios. And what's very useful about this is we can see when you get to overshoot, what sort of reasons for concern are really affected basically by the overshoot. So you can link overshoot to particular ecosystems. Of course, unique and threatened ecosystems or threatened systems are particularly at risk from the overshoot. The representative key risks, which was a new approach coming out of Chapter 16, identified these 7 major representative key risks. The first one being biodiversity loss, damages and transformation of ecosystems. And we concluded they will continue to escalate with every increment of global warming with very high confidence. There are risks to physical water availability and water-related hazards. Also will increase with high confidence. We will see increasing pressure on food production and access, especially in vulnerable regions, undermining food security and nutrition. Extreme events will significantly increase ill health and premature deaths. We see significant risks to city settlements and key infrastructure. Projected estimates of global aggregate net economic damages, we now find will generally increase in a non-linear fashion with global warming. And that's an interesting new finding. And in the medium to long term, we see risks of human displacement with increasing intensification of heavy rainfall and associated flooding. So all in all, a set of very significant representative key risks, all expected to increase with very high confidence to very high confidence. Just to get a little bit more detailed on impacts and risks to terrestrial and freshwater ecosystems, which is an area in which I've been working with some detail, we can see that we've split this representative key risk into components: biodiversity loss, structural change, mortality of trees, increases in wildfire, and losses of carbon from ecosystems. And we can see that structural change of ecosystems has been going on for quite some time. So you can, structural change starts very, very early with global warming and apparently with rising atmospheric CO2. While biodiversity loss kicks in a little bit later, tree mortality is quite early. But you can see that the risks to these ecosystems will really start to increase above 1.5 and 2 degrees. So that strongly supports those initial conclusions from AR4 and AR5 and AR4. I did say that we'd started to include adaptation into these sorts of assessments. And here you see the results of that effort, particularly here for health outcomes. And you can see that the risks with limited adaptation are given on the left-hand side of each panel, so heat-related morbidity and mortality, then with incomplete adaptation, and then finally proactive adaptation. And what it shows is in this particular sector, how adaptation, particularly planned adaptation, can really buy you a lot more time, a lot more climate space before you shift into high risks. And the message from the team who did this is that this is very, very hard to do because the results from adaptation studies are just not presented in this way. So one has to try to distill them out. And it's a call, I would make a call to the research community. When you're doing an adaptation study, try to express your results in terms of how much warming does it buy you, how much more risk can you avoid, rather than how much do you reduce your risk at a particular temperature. How much warming does it allow you to, risk does it allow you to avoid? So that would be a call to the research community. I did want to throw this one in very quickly because it talks about who is responding by region and sector. And this is a really great result for Africa because it shows that in terms of responses, measured by just the number of publications. Okay, so it's a fairly coarse measure, but look at this. Africa and Asia are just way ahead of all the other regions, according to this particular literature review. So that's something that I think we can pat ourselves on the back for, and long may this last, and may we increase this ability. On the other side, quickly looking at African adaptation responses relative to responses of other regions. And here you see a kind of a spiderweb diagram showing adaptation in terms of technological responses, institutional, behavioral, cultural, and nature-based. These are estimates from the chapter, and they show that Africa at the top here is very strong on behavioral and cultural adaptation, a little bit less so in nature-based and technological. But of all the regions, Africa and Asia have the weakest institutional adaptation responses. This, I think, is an extremely important message, and one which we can really work on as a region. A new thing that came in, and this is thanks to the work of the Africa chapter team, some key risks expressed in the burning embers format for Africa, showing beautifully the risks to biodiversity, loss, ecosystem disruption, mortality and morbidity from heat and infectious disease, and reduced food production. And now we can start to see for the African region, relative to the rest of the world, where do our risks lie? So this is a great advance, and I think a real feather in the cap of the Africa chapter. I'm getting towards the end, and I wanted to pop up this little set of maps that is in the Africa chapter. Well done again to the team. And what this set of maps shows is firstly changes warming in freshwater ecosystems as observed, but also observed changes in ecosystem structure, changes in the way that ecosystems look across the African continent. And it's quite an extraordinary message, because you can contrast both losses of ecosystems, the loss of grass cover and gains of grass cover and losses of grass cover versus the declines and gains of shrubs and trees. And you'll see a lot of green icons around the continent, which indicate the woody plant invasion or greening up of these African ecosystems, with certain areas where there is a significant amount of loss recorded. So this is by no means a one-way street for African ecosystems. We are seeing some changes and increases in cover and possibly in net primary productivity. And part of this, the authors surmise, is driven by rising CO2 and the effects of the fertilization effect of higher CO2 on the growth, particularly of woody plants. And they've proposed this model in the report, which is a very interesting one to look at, and we can ask questions about it. I would prefer to see some reference to wildfire in this figure, but nonetheless, I think it's a useful figure. Thank you very much, and I do appreciate your attention.
Thanks very much, Guy. Lots of questions associated with that, but we'll hold those for later. I want to move straight on to Trisos, ACDI, University of Cape Town, and he's the coordinating lead author from Chapter 9 on the Africa chapter. So, Chris, over to you.
Great. Hi, everyone, and thanks to Guy for that overview of key risks globally and biodiversity. This is a deeper dive into the Africa chapter. In the interest of being brief, I'm going to present just a selection of some of the information that's new in the Africa chapter since the previous report. There is much more, and I would encourage you please to go and read the Africa chapter, the sections that interest you in full. And so to start off on the climate change side, average and extreme temperatures are rising, and this is attributable to human-induced climate change. Marine heat waves around the continent of Africa are about twice as likely because of human-induced climate change. We've seen multi-year droughts becoming more frequent in West Africa, and the reduced rainfall that led to the Cape Town droughts 2015-2017 has been assessed to be around 3 times more likely because of human-induced climate change. So this is just a snapshot of some of the changes in climate hazards, physical climate hazards that we've seen. And so the drivers of those changes in hazards are increasing greenhouse gas emissions. And historically, most African countries have contributed relatively little to the greenhouse gas emissions which cause climate change. South Africa is an exception as a relatively high greenhouse gas emissions country globally. You'll see in that bottom panel we're the highest out of the African countries, but most African countries have contributed relatively little. And yet, in this report, a real advance for the sixth assessment report in the African context is that Africa has already experienced widespread losses and damages that can be attributed to human-caused climate change. These include reduced food production, reduced economic output, loss of biodiversity, and increased human mortality and morbidity. And so to skim through some of the information in the report on these, there's been an expansion of Anopheles mosquito vectors. So this is for malaria to higher altitudes in East Africa with increasing temperatures. There's increasing incidence of malaria with increasing temperature. The human-induced climate change link for malaria is weaker in that instance. However, in the case of cholera outbreaks, there's an increase with increasing temperatures, also especially following tropical cyclones in East Africa and Southern Africa. With heat, around 44% of heat-related mortality since the 1990s in South Africa has now been attributed to human-induced climate change. On the food security side, we've seen an increase in growth in agricultural productivity, but that growth rate has started to decline. And in the case of Africa, there's been about a 34% reduction in the growth of agricultural productivity due to climate change since the 1960s. And this is a larger reduction than in any other region assessed in the report. In sub-Saharan Africa, maize yield declines of around 6% and wheat yield declines of around 2% have been attributed to climate change. And then in social opinion surveys, around 2/3 of Africans perceive that climate conditions for agricultural production have worsened over the past 10 years. So not only are we seeing the climate change impacts on crops, but broadly across Africa, Africans in the agricultural sector perceiving that the climate is changing and that these conditions for agriculture are worsening. People are noticing these changes. Turning to economic impacts, this is a much expanded part of the report compared to the previous report. There's high confidence that climate change has had negative economic impacts across Africa. Particularly, it has increased income inequality between African countries and countries in more temperate northern hemisphere climates. Losses to economies have come primarily through losses to agriculture, also to tourism, manufacturing, and damages to infrastructure from extreme events. One tourism example is the decline in tourism experienced in Cape Town during the Cape Town drought. However, agricultural productivity losses affect economies widely across Africa because over half the African workforce is employed in the agricultural sector. GDP per capita on average, according to one estimate, is around 13% lower from 1991 to 2010 compared to a counterfactual scenario of if climate change had not occurred during that time. And at a local scale, climate impacts that reduce productivity, such as agricultural productivity, lead both to lower macroeconomic performance, but also to some severe impacts in local areas. For example, case studies in South Africa suggest that in some towns, around 80% of businesses lost over half of their employees and revenue due to agricultural drought. The report also goes really in depth into looking at future risks, projected impacts, what will come. And so this slide was shown by Guy. This is the burning embers diagram, how the risks increase for Africa. There are more key risks identified for Africa than just biodiversity loss, mortality, morbidity effects, and reduced food production. However, these are the three for which we had extensive enough information on projected risks in the future to construct these diagrams. And so we're at around 1.1 degrees Celsius of warming at present, and 1.5 degrees Celsius under many scenarios is more likely than not within the next couple of decades. And so by that level, we're starting to see large regional crop losses. For example, in South Africa, there's a projection across many models of a more than 50% decline in the wheat yield, even when implementing adaptation options. You're seeing increased inequality and poverty within the next decade in a high warming scenario with economic growth that is not inclusive. Some estimates suggest an additional 40 million people in Africa could be pushed into extreme poverty. There's increasing drought in the southwest of Southern Africa, increasing risk of heat mortality. Just over 1.5 degrees Celsius, for example, parts of West Africa may see up to 50 or over 50 potentially lethal heat days every year. By 2 degrees Celsius, the risks in Africa become severe and widespread and potentially irreversible in many systems. For example, up to 18% of species could be at risk of extinction around 2 degrees Celsius in an African context. We could have an over 30% decline in fish catch potential along parts of the tropical African and Southwest African coast. And this could place close to 300 million people at risk of malnutrition from micronutrient deficiencies such as vitamin A, vitamin B, iron deficiencies that they get from fisheries. And this would be especially detrimental for pregnant women and children. And there could also be widespread crop losses. Above 2 degrees Celsius, there's high confidence for staple crops in the report that even with adaptation options, there would still be net losses in many crops. So reaching hard adaptation limits above 2 degrees Celsius for some food systems in Africa. So this emphasizes the need for urgent action. The report is clear, the science is unequivocal that rapid and deep emissions cuts are required to limit severe risks, along with ambitious adaptation action. So we need both the mitigation and the adaptation. And this is an example here is around the benefits of this action. So limiting warming to 1.5 degrees rather than 2 could result in GDP per capita in Africa being at least 5% higher by 2050 and potentially 10 to 20% higher by 2100 across nearly all African countries. So just to highlight some of these adaptation options and their limits, this is also something that was done extensively across the Africa chapter, and more panelists will speak to this, but to give an overview here. So first, adaptation has been observed to be largely fragmented and local and incremental, rather than the rapid transformative adaptation that is projected to be required to reduce future climate risks. It's often at the level of individuals or households. In an African context, indigenous and local knowledge are extremely important for adaptation actions. There's evidence in the report that social protection programs and environmental protection programs can be very effective at reducing future climate change risks, and especially when these two things come together. For example, in South Africa's Working for Water program, where people are given employment, they're given that employment in sectors where removing invasive alien trees from water catchments can increase water security under projections of future climate change. It doesn't completely reduce the future climate risk, but it's an example of a project that's providing both employment and social protection and at the same time reducing the climate risk to those environments in the future. However, for 89% of African cities, so a large portion across Africa with more than 1 million inhabitants, there were no adaptation initiatives reported in the literature. And so some of this is a research gap, but it also suggests that widespread across Africa, the long-term planning and human settlements needed for adaptation is not being actioned today. So what are these barriers to adaptation in Africa? Again, there was an extensive search of the literature here, tens of thousands of papers, and the main information that comes up around these barriers are governance and institutional policy stands out as a barrier, so does finance, and so does information awareness and technology as major barriers. And to highlight just two of these here around finance, this is finance for research on climate change in Africa. And to date, Africa has received only around 4% of global climate change research funding. You'll see this in the blue versus the orange line on the bottom left-hand panel here. So Africa, given how vulnerable it is to climate change, has had a disproportionately small amount of research funding allocated to understanding that problem. And to make matters more difficult for African researchers, most of the funding for African research on climate change has not gone to researchers in African countries. It's come from developed countries such as the United Kingdom and the United States, and it has gone to researchers in those countries, as you can see in the top right here. And there's also been a skew in where these research efforts are focused for understanding climate risk and adaptation options, much more towards food systems and ecosystems. Appropriate, those are major risks. But there's a requirement to increase the amount of funding going to other major risks, such as climate change risks to urban areas and cities, to poverty and livelihoods, to security. So this is just a map from a global survey of papers showing how few adaptation research papers are done on individual African countries. There is a relatively high amount of research in parts of East Africa, South Africa, and West Africa. But for most of West and Central Africa, North Africa, there's an extremely limited amount of research on adaptation options and their effectiveness. Moving on now to climate finance at a higher level, so not just for research, but this is finance focused on adaptation and mitigation, coming from developed country governments, multilateral development banks such as the World Bank, international funds such as the Green Climate Fund. There's high confidence that the amount of finance flowing for adaptation is lower than even the lowest adaptation cost estimates. So this indicates a requirement to increase finance targeting adaptation by billions of dollars per year going forward. And there seem to be challenges, especially for climate programs and even more so for adaptation programs in this financing. And so what this figure on the plot, what this plot here is showing is that adaptation finance, so finance targeting adaptation projects, this might be in agriculture and ecosystems and health, only about 46% of finance that is committed to those projects has actually been dispersed up to 2018, which is the most recent data at the time of this report being compiled. And if you compare this to other development projects in an African context, around 96% of funding committed to general development projects is dispersed. So there are lots of barriers within the funding pipelines and the readiness requirements and the funding implementation requirements that are slowing the disbursement of adaptation finance in Africa. And so there's a massive requirement, not just to increase the finance, but also to increase the access to the finance and ensure that those projects that are financed are actually implemented on the ground and the finance flows to them rather than staying as commitments on paper. And so with that, thanks very much. If you are interested in further reading the chapter or there's just a short 2-page fact sheet, please check out these links and I'll hand over to other presenters. Thank you very much.
Thanks, Chris. Okay, we're running a little bit behind time and I'm not going to make any comments on that at this point. We want to get through into our panel discussion and I'll ask our panelists to really speak succinctly and stick to their time so we can still maximize our group discussion time at the end of that. So without further ado, I'm going to hand over straight to Professor Felix Kalaba. And he's speaking on ecosystem-based adaptation, and he is lead author from the Africa chapter. Felix, are you available and ready?
Yes, thank you so much. So around ecosystem-based adaptation, it is important just to remind ourselves that this is basically using of biodiversity and ecosystem services to assist people to adapt to climate change. Now, this is particularly important for Africa, where we know we have high rates of vulnerability, and these high rates of vulnerability are happening within the region where the majority of people depend on natural resources-based livelihood strategies. So what we did in this assessment is that we looked at a number of sectors that are implementing or planning ecosystem-based adaptation, and we reviewed the 52 nationally determined contribution NDCs documents. And out of the documents that we reviewed, we found that 36% of adaptation actions in 52 countries across Africa are actually within the EBA, that is the ecosystem-based adaptation. And further, we found that out of these, 83% of the adaptation strategies that have been proposed actually fall within the agriculture, environment, forestry, and water. Now, if you look with me at the figure that is before us, you will notice actually the various sectors as well as subsectors. You can see that there's a lot of emphasis around ecosystems and biodiversity, as well as land and soil management, also sustainable forest management. Now, the other thing that we noticed then from our assessment of literature is that there is a high agreement that the costs, the challenges, and the negative outcomes of EBA interventions are still poorly understood across the continent. But one of the key things that is coming out is that there are a number of financial constraints associated with the implementation of this ecosystem-based adaptation. And going then into literature, trying to really narrow down in the four sectors, the four important sectors, that's agriculture, environment, forest and other land use and water. What we found is that there is a lot of agreement in literature on the role of improved soil and water conservation, as well as around improved agricultural productivity and drought resilience. Now, within Southern Africa, this is something that is quite pronounced when you look at a number of indices, as well as you look at the literature out there. And then around the environment, there seems to be a strong emphasis around livelihood diversification opportunities. Now, as we look at livelihood diversification opportunities, which have been identified as being medium, if you look at the literature, one of the key challenges that we find also there is that as we look at the livelihood diversification, the options, alternatives that are available for people still remains low. And then moving on to, last but not least, I think the water sector, there is also a lot of emphasis around integrated water catchment management. And this is obviously because of the need for the water, both in agriculture, sustaining agriculture, and also in generally helping people survive both in urban and regional, urban and rural areas. I would also quickly maybe just comment one or two things around tropical forests, because I happen to have laid the cross-chapter paper on tropical forests, where just a few issues that needs just to be highlighted is the fact that the climate change is actually changing this structure and species composition in tropical communities. And this includes what Guy earlier on, I think, alluded to, this transition from moist going more into the drier forest. And this is actually also weakening the carbon sequestration potential of tropical forests. And a number of things have been highlighted that points to how we can adapt as well as survive under these rough conditions. But more details are provided in the chapter. Thank you so much.
Thank you very much, Felix. You kept your time. That's very helpful. I hope people are making notes and developing some questions for the discussion. Can we move directly then on to Dr. Portia Williams from the CSIR, also Africa chapter, speaking on adaptation, feasibility, and effectiveness. Portia, are you there?
Yes, I'm here, Bruce. Thank you. So I'm going to dive into what the report says, adaptation options feasible to our African context. Looking at some of the striking grim projections that are detailed in the report, we all need to act fast. So what is important in the Africa chapter is the huge knowledge and information to draw on, as the report makes clear, a number of solutions that relate to sectors like water, to agri, to cities, to health ecosystems across various African regions and countries. It also details how progress on adaptation has been observed across these regions. So specific solutions across all of Africa is very hard to say, because we know adaptation strategies are quite context specific and applicability varies according to geographical settings. So the report, through its first ever multidimensional and feasibility assessment for 24 promising adaptation options that are applicable to the African region, show more relevant options that we can choose from. So the examples given are recorded strategies and actions that are empirically observed within studies done in Africa. And they are feasible and effective options that can reduce risk for people and nature. In the report, the feasibility assessment was done selecting the adaptation options across about 6 feasibility dimensions, looking at economic viability, environmental, social, institutional, technological, and potential risk for reduction factors. Again, we also went ahead to engage about 56 experts on the African region that were consulted in an expert-driven elicitation process. And I must say it was quite comprehensive, and I would encourage everyone to go and look at the report. Giving a brief idea, probably in 3 minutes, I would say that looking at it sectorally, for improving food security, we have effective options like agroforestry, farm and landscape diversification. We have changing crop and livestock mixes, amongst others. For water sector, we can talk about options like sustainable water management, like for food production with specific options like irrigation. We have rainwater storage. Also for irrigation, you can have watershed restoration. And there are also wider options within the water sector that are reported, such as bulk water infrastructure. Interestingly, sustainable water management, that category is widely reported, and the feasibility would depend also on socioeconomic conditions. As we all know, African farmers, they can't afford the cost of facilities like rainwater harvesting for irrigation. For transforming cities too, there are a number of effective options that are listed there, which include infrastructure and built environment. So talk of options like developing flood prevention infrastructures, improving drainage, social safety nets for disaster management. So in construction of resilient infrastructures, it's quite expensive, and across national and local level, planning for such options poses some challenges. That's where finance and institutional capacities also comes in, showing inadequate institutional capacities and limited access to adaptation finance as one of the key limits to adaptation, human adaptation, that is highlighted in the report. I know time will not permit me to go on with each adaptation strategy, but I will say here that apart from Central and North Africa, majority of the adaptation options in the report have been observed in other regions, including South Africa. And as a major highlight in the report, none of the responses that were assessed have high feasibility of implementation across all the dimensions. So feasibility is mainly higher, you see, along the social dimensions. And most of the options have medium effectiveness as at reducing the risks from present-day global warming. So we would say that the efficacy for future warming it wasn't unknown. In the report, we have highlighted that there is limited evidence to assess continued effectiveness at higher levels. So I'll quickly say the report also outlines and notes that some options reduce socioeconomic inequalities. Others also have access, like access and provision to climate information services, agroforestries, and all that, having some co-benefits with its implementation. Yet, on the contrary, you also find some options that induce trade-offs with mitigation objectives, and which we have all highlighted. So for an option, it is better if it is more inclusive, it's more equitable and effective to remove underlying vulnerabilities. And these initiatives are all moving in the right direction with actions to prevent natural forests and other sectors, and also to have a sustainable future for all. Thank you.
Thanks, Portia. Thanks for keeping it to time. We need to move on so we can get to our question time. Nick Simpson from ACDI at UCT, speaking on climate literacy. Nick, are you available?
Afternoon. Hi. Yeah, I'm here. Climate change literacy. How we respond to climate change is affected by our perception of change and an understanding of its causes, impacts, and future risks. In general, people with the knowledge of the human causes of climate change and who have experienced its impacts are more likely to understand it as a serious threat. The key message in the Africa chapter highlights the role of climate change literacy to improve responses to climate change with a specific emphasis on climate services. It states with high confidence, climate information services that are demand-driven and context-specific, combined with climate change literacy, can be the difference between coping and more informed adaptation responses. So climate services promote climate resilient development by providing important information for adaptation decision-making. However, scalable uptake of climate services relies on climate risk perception of users, which largely driven in Africa by experience and perception of local changes. One reason for this is the production of salient climate information in Africa. One thing that hampers this is the production of salient climate information in Africa is hindered by limited availability of and access to weather and climate data. But the knowledge base for informed climate responses by end users of climate services and everyday people across the continent is further affected by their perception, awareness, and literacy. Perception of climate change in Africa can occur without knowledge of its human causes and its effect on risk. This can lead to coping or what we call reactive responses, unplanned responses to experienced climate change, and falls short of adaptation. At a minimum, climate change literacy includes having both heard of climate change and understanding it is, at least in part, caused by people. Advanced levels of climate change literacy include knowledge and skills enabling individuals to make informed decisions and actions. Understanding human causes of climate change is a strong predictor of climate change risk perception and can enable responses to climate change that go beyond reacting to climate change or business as usual responses. I'm going to share my screen quickly to share a figure from some of the underlying literature that shows, although across Europe and North America, climate change literacy rates are generally over 80%, large inequalities in climate change literacy exist in Africa. National climate change literacy rates in Africa average only 39%, with large variations within and between countries. Gender difference also varies between 5 and 25% across African countries. 60% of countries indicate a difference between men and women of greater than 10% in climate change literacy rates. 11 of the 15 largest gender gap countries are in West Africa. These are concerning because women are often more vulnerable to climate impacts in Africa than men. The Africa chapter also highlights that poverty undermines climate change literacy and that perception of droughts and floods are getting worse by those in poverty highlights exposure to climate change impacts by those with the least adaptive capacity. Observed drivers of climate change literacy overlap with broader developmental challenges on the continent, affording opportunities for co-benefits between progress towards the Sustainable Development Goals and climate action, particularly for education, gender, and poverty reduction. So progress towards greater climate change literacy could also afford a concrete opportunity to mainstream climate change literacy within core national and subnational developmental agendas in Africa. Thank you.
Thanks, Nick. That really touches on something that's really close to my feelings on things as well. Let's move on quickly then so we can get to discussion. We're going to move on to Dr. Edmond Totin, from also lead author for the Africa chapter. Edmond, are you ready to take over?
Yes. Thank you, Bruce. Well, I'm going more specifically to talk about adaptation in food systems. And of course, from what Chris already painted in terms of impact, we see that there is a need for rapid action. And coming from Africa, we mapped a couple of adaptation options that can be considered in policy and program in Africa. And as Portia mentioned, those are quite generic, and the feasibility and effectiveness assessment can help countries and also sub-countries to identify which option can work where. And so the first is the African knowledge, indigenous knowledge and local knowledge can provide a rich foundation for adaptation options in Africa. And we see in countries like Burkina Faso, a local community, just by seeing the directions or the speed of the wind, they can predict whether they will have rain or not. Those kind of information is quite crucial for farmers to make informed decisions. Another option is the early warming systems based on targeted climate services that can be effective in risk reduction. But the major challenge we have in Africa is the existing weather infrastructure remains suboptimal to enable reliable early warming systems. And the report shows that only 10% of global weather stations are in Africa, of which 54% cannot capture data accurately. So, well, that this is a major gap. Another adaptation options that we also mentioned in the report is agricultural and livelihood diversification data strategies that can be used in African households to reduce risk. And this include adjusting cropping choices, planting time, or size, the type of location, planted areas. We also mentioned the use of drought-tolerant crop varieties, and this is can be considered. But the major challenge of it is that the access to availability and affordability of those seeds. And we know that those high yield varieties are not accessible mainly for smallholder farmers. And this is the kind of option to be considered carefully and not to create a kind of inequity in society. The report also mentioned agroecological and conservation agriculture, such as intercropping integrations of legumes in the cropping systems, mulching to manage water more carefully and make use in a more careful way. Portia mentioned some irrigations, and this is also something that we highlight in the report. But it's really about the small-scale irrigations and to allow farmers to have a better control of it. Of course, it require resources that some farmers may not afford. It's also a kind of careful planning because it can lead to maladaptation. We have seen many countries where irrigation was promoted without a careful planning, and it led to another kind of disaster. So those are the kind of things we mapped as adaptation option from Africa chapters. And I invite everyone to take a look at the Africa chapter as well. Thank you.
Thank you, Edmond. Thank you for being so concise. We have two more panelists to speak. Luckson from UCT, speaking on indigenous and local knowledge. I think that's close to the heart of many people. Luckson, can you take over quickly?
Thank you, Bruce. I think I have to make this clear that this is the first time for Africa chapter to have a whole section dedicated to indigenous and local knowledge. So it's a great improvement from the African. So I'm going to run quickly through the key findings from our assessment. And it was quite clear that the evidence of the use of indigenous and local knowledge to adapt to climate change is growing in Africa. And it is providing very valuable information, particularly to vulnerable groups such as the smallholder farmers on climate forecasting. And the evidence is quite clear that in Southern and East Africa, many smallholder farmers and communities are using this information, are using this knowledge to predict weather patterns, to forecast seasonal changes, forecast seasonal changes. And it is also, we also found out that many of these smallholder farmers and communities that are relying to indigenous and local knowledge are showing high reliance to the knowledge. And we also find out that in many instances, governments are now working with local communities and smallholder farmers to try and elevate indigenous knowledge into national policies, into ways of better disseminate this weather forecasting. So that's a huge step forward in terms of elevating the indigenous and local knowledge in Africa. And we also, our findings also highlight that indigenous and local knowledge-based adaptation measures are recording relatively high risk reduction. And although these measures are, most of them, they are incremental and supportive measures. What this means to policymakers and governments is these measures, the indigenous and local knowledge base, they cannot be used as standalone adaptation measures. What they need to, what is needed going forward in Africa is just try and integrate these rich indigenous and local knowledge in our communities with other sources of knowledge, with other scientific proven knowledge to increase the effectiveness and efficacy of the indigenous and local knowledge. And some of the indigenous and local knowledge that we found out that are mostly used by farmers include the change of crop type from the traditional maize, which is the staple in most African countries, to drought-resistant varieties such as the sorghum and millet that can stand the high heat pressures. And also the use of indigenous knowledge to inform the early burning to try and mitigate the intensity of late season fires, which has been recorded in countries like Namibia. And we also found out that African indigenous languages, they're playing a key role in terms of disseminating these climate forecasts. So what this means is going forward, indigenous knowledge must be indigenous communities must try and work with scientific knowledge producers or scientific focus to try and use indigenous and indigenous knowledge, indigenous languages to disseminate weather forecasts. And we also found out that there are limits to the use of indigenous knowledge in Africa, which is particularly to do with the lack of the recognition of indigenous and local knowledge, particularly at policy level, although the efforts are there to try and elevate the knowledge. But from a general perspective, there are still gaps in terms of how this knowledge is being perceived at government levels. So I think these were the key findings from the indigenous and local knowledge contribution to climate adaptation in Africa. Thank you, Bruce.
Thank you, Luckson, for keeping to time. That's great. Okay, our last panelist is Chris Lennard from UCT, and then we'll go into a Q&A time. So please be thinking ahead of time now about what sort of questions you might want to be asking. Chris?
Thanks, Bruce. I misunderstood my brief. So I was supposed to talk to you about the climate messages, but I'm not really. Just to say that everywhere gets hotter in terms of extreme heat events. They start happening sooner in Africa compared to the rest of the world, mostly developed nations. In terms of rainfall, the message is a bit harder to get at. In terms of extreme rainfall and mean rainfall, largely in the western parts of Southern Africa and the northern parts of North Africa, we see very strong messages about mean drying, so general drying of those regions, and then also heavier extremes. What I actually prepared builds on what Chris Trisos was saying earlier about capacity development. So I'm involved in something called Codex Africa, where we try and develop the African scientists to do climate science in Africa. And what we assessed in our chapter in terms of African capacity to do science is that we found that most of the papers written about adaptation, vulnerability, or impacts are not written by African scientists. And if they are, most of the author teams are European, and if there is an African on the paper, they largely sit right at the end. So most of the African climate and VIA science is not being done by Africans. Furthermore, again, building on what Chris said, is we assessed that between almost 4% of global funding for climate change research is focused on Africa. So if you think Africa's been called the most vulnerable continent to climate change, less than 4% of research is being dedicated to understanding why and what we can do about it and how we should adapt. And almost all of that funding, as Chris again said earlier, most of that funding goes back to Europe or goes back to the US. African scientists or African institutions only get about 0.6% of this funding coming into our institutions. So climate-related research in Africa faces very severe funding constraints, and there is unequal funding relationships between countries with respect to research partners in Europe and North Africa and Africa. And this is problematic because the funding, if research is being done by northern folk, then they bring with them their northern cultural norms and their ethical norms and their epistemological frameworks and their heritages. So their frameworks get imposed on Africa. And the solutions for Africa are northern solutions. They're not African solutions. So researchers at the Global North institutions can shape the research questions and the research outputs, rather than providing actionable insights for use by African partners. And this can actually reduce the adaptive capacity of Africa instead of assisting us with climate resilient development. So it is a problem that, or we assess that there's an issue here with African scientists not actually doing VIA science for Africa. We also assess that this is not the only hindrance, that most of the work is being done in the north, the global north, but also with respect to infrastructure in terms of observations. So with our climate messages, we can say our messages are very weak in terms of rainfall change in Africa because there are very few measurement stations for rainfall. And I'm using a rainfall example, but Guy showed that figure earlier on with vegetation biomes. And you could see in that figure, there are very few observations. So we don't actually know, we have high levels of uncertainty, particularly with our rainfall change. And in Central Africa, across Central Africa, we really have to assess with low certainty observed rainfall change. We just do not have the observational infrastructure there. And then that's the first thing. And the second thing is that the in-country support lacks to do this, to facilitate this type of research. So Chris said earlier, and we've written it in the report, that governance, institution, and policy can be a hindrance to adaptation in different countries. And this is not global governance, it's talking about in-country types of governance. So what then is some of the solution space to produce actionable insights to research climate impacts and actually develop actions? The first is we write this and we say increased funding from African and also non-African sources, but Africans need to be a part of developing the questions that funding is directed to. Then also projects that are funded by non-African agencies or NGOs, increasing direct control of resources for African partners, and having African researchers and African priorities set the research questions and identify the skill gaps that exist. So in summary then, we assess a lack of capacity within Africa generally to conduct climate and vulnerability impacts and adaptation science, and also in the sphere of climate services. And this capacity gap, climate resilient development can be more effective if this capacity gap is addressed through funding by African and non-African funding, and also by governance and institutional policy that facilitates this type of research. Thanks, Bruce.
Thanks, Chris. That is a really good way to end talking about the African voice and African capacity. So we're going to go into a Q&A time. We will take spoken questions. Please raise your hand if you want to ask a question, and we will identify you and call on you by name to pose your question. We do have some written questions if nobody is raising their hand at this point. I don't see any raised hands at this point. So I'm going to jump to one of the written questions at the moment from Mira Shah. Mentioned adaptation funding to Africa is lower than the current lower than the even lowest estimates of costs. What are the latest estimates for cost of adaptation in Africa, please? Chris, Trisos, would you like to have a quick answer at that? And then we'll take a spoken question.
Sure, thanks, Bruce. The current estimates vary widely. So by some estimates from the African Development Bank, implementation just of the nationally determined contributions from African countries range between $7 to $15 billion per year. But then looking in the near-term future, estimates are as high as many tens of billions of dollars, $50 billion or even higher. Depending on methodologies, there's a wide range of estimates, but current finance flows are in the order of like less than $7 billion per year for adaptation, targeted adaptation in Africa. So that's why we can say with confidence that current flows are lower than even the lowest adaptation cost estimates. Thanks.
Thanks, Chris. That's good. Okay, we're going to jump to Ephraim. You had your hand up first. Can you unmute and pose your question?
Thank you. Thank you very much. Yes, my name is Ephraim Shtima. I'm currently the chair for the African Group of Negotiators. Now, first of all, I should say it's exciting to see so many experts from Africa participating in the IPCC work, because we've been looking forward to this, and this is commendable. I'm sure you know that Glasgow indicated that we have a huge gap in terms of the NDC ambitions, the collective NDC ambitions, and synthesis report showed, and what is required to be done. And therefore, countries are requested to revisit their ambitions before COP27. I know it may not be a purely scientific question, but you also know the contribution of Africa in terms of global emissions. From your scientific perspective, what recommendation would you have for the African countries in terms of raising their ambitions in the context of the scientific imperatives that we have, but also taking into account our sustainable development needs? Thank you.
Okay. Thank you. I'm not sure who to point that question to. Does any of the speakers want to pick it up?
I can come in. IPCC doesn't give recommendations, as you well know, but it's very clear that African institutional responses are amongst the weakest, in addition to Asian ones. So that's clearly an area where one could focus efforts very productively. Thanks,
Guy. Andrew, can we move over to you then?
Yeah, I have a question for Chris Lennard. I've been noticing on the Codex website that predominantly the RPC projections are 2.6 and 8.5. What is the reason for not having the 4.5 RCTs available anymore?
There should be 4.5 projections on the ESGF website. They were part of the experimental design. So there should be 2.6, 4.5, and 8.5. Maybe just one thing on the 8.5, we got a lot of pushback against, not against, but there were some very critical reviews of the work that we did based on RCP 8.5 because it's a very unrealistic RCP. But Andrew, maybe this is a correct question. Just drop me an email and we can address it offline.
That's good. Thanks. I just want to go back. We've got Kingsley's question written in chat. How are we incorporating climate change actions and impact assessment of studies? I'm not sure who to pass that one over to. Any one of the speakers want to volunteer to take that one?
Sure. Sorry, Bruce. If I was answering in the chat, is this Kingsley about incorporating climate change actions in impact assessment studies?
That's the one.
So in the context of the report, I think what does speak to this is the clear need for what we call an all-of-government approach. And so that's seeing climate change not just as the remit of the environmental ministry or the agriculture ministry in a country, but that it speaks also to the treasury or finance ministry, the presidency. And so it requires multiple ministries coming together to prioritize climate change risk, and responding to climate change risk is very high level. And part of that is including climate change impacts in environmental impact assessment and long-term planning, especially in human settlements, where taking action now for the long term is often, if you take action in a reactive way or in a very short-term context, it's not nearly as effective at reducing climate change risk. So part of this is all of government approaches right across the government ministries having a strong focus on climate risk. And part of that is mainstreaming the climate change into future planning and impact assessment studies, environmental impact assessment studies, considering climate change would be a core part of that. Thanks.
Thanks, Chris. Just want to note that if you are posing questions in chat and we don't get to them, we will collate all these questions and hopefully we'll have some responses from the speakers after the fact. Can I move on to Michael? Michael, can you pose your question?
Yeah. My first question is about the issue of integration of indigenous knowledge. And we are looking at the African meteorologists. So to what extent are the African meteorologists, forgetting about the meteorologists from the West, how are they integrating indigenous knowledge into the African climate services? Then the second one would be more of a comment. There was an issue about the number of papers and the issue of research from Africa. But I tend to think that we also have a challenge that many of our African writers tend to publish into journals which don't seem to be accessible when the peer review mechanism of the IPCC is done, because they tend to use, I think, Web of Science, but since people like Mark New can help us how they search the papers. So there's a possibility that those papers that are published in our national journals or regional journals, which don't seem to be part of the global Web of Science or Scopus, could be missed out. How can that be addressed? Because there might be a lot of science that we tend to miss out from African researchers by virtue of being in regional or national journals, which may not be part of the wider global system. Thank you.
Thanks, Michael. I'm going to pass on your second question because that's a big structural question that needs a lot of discussion. But your first question, I think maybe I can ask Luckson to answer that about how indigenous knowledge is being used in meteorological services. Luckson, can you handle that?
Yes, thanks, Bruce, and thanks, Michael. And I think I need to highlight this. From our analysis, we only noticed like 3 strong case studies where meteorologists are working with indigenous knowledge holders to try and integrate indigenous and local knowledge-based focus with scientific focus. So I would say the rate now in Africa is low, but it's quite commendable that there is something that is going on in terms of trying to work. In terms of trying to get together meteorologists and indigenous knowledge holders. So we hope that in future these case studies will keep growing, where these 2 stakeholders are working together. Thank you.
Thanks, Luckson.
If you allow me, I also want to elaborate a bit on this.
Please do, Edmond. Yeah, jump in.
Because we often mention the integration of scientific and local knowledge, but how this can happen in practice. So I believe that this requires a kind of mental shift. Because often scientists only trust evidence generated through a rigorous Western science-based protocol, while local knowledge, we don't have this kind of rigorous methodology in place. So we think that this mental shift could create space for the decolonization of climate science. The second thing I can also flag here is a joint work where we have our local community working with scientists, with Western-driven scientists to generate evidence together. It's not one side is above the other. It's really calling for kind of joint work. The integration will start from the way they work together. So those are the few things I want to mention. How best we can come to this integration.
Bruce, okay that I can also maybe just comment on that also on the second.
Coming quickly, yes.
Yes, so I think one of the challenges with the African traditional knowledge is that it has not been documented, and I think there's need for researchers and local communities work together and document this so that this can be tested. Then moving on to the next question that talked about the literature. Yes, when you look at the IPCC process, we reviewed the papers on using different search engines, but also grey literature. So with grey literature, meaning that we're able to access documents online and then archive them also with the IPCC. But I think one of the things that we need maybe to encourage ourselves as scientists is to ensure that the various journals that we may have, regional or national, if they can find themselves a list to the internet, that would be of great use, because that is actually the stop. So the literature that we have is not just Scopus journals, but also grey literature. Thank you.
Thanks, Felix. That question really has touched on some very systemic issues that are embedded in the process. And that is a long discussion, and it's been an ongoing discussion for a long time. Okay, I want to move on to get as many questions as possible. Lara, would you like to jump in? Are you still there?
Yes. Can you hear me?
Yes, I can hear you.
Thank you. I have a quick question, but I can also defer if somebody else wants to go.
Go for it.
I looked at the report in terms of the adaptation strategies, but also the loss of biodiversity in the ecosystem service they provide, so like water security, carbon sequestration. And what was amazing in the report is that they've generally upped the target significantly. Between 30 and 50% of the natural world needs to be protected and conserved. And then it was, and this is something that's quite hard hitting and coming through to developed countries, because most of the natural ecosystem is sitting in the developing countries. So I was a bit wondering why it wasn't that clear these targets had support in the African fact sheets or in the Southern African fact sheet. Because traditionally, that's not something that's always very well supported by our governments. And so it's going to take some serious messaging to get buy-in. And I don't necessarily mean formal protection, but some sort of a conservation and protection. So I was just wondering if there was maybe a message behind that, why it wasn't explicitly included in the messaging. Thank you.
Thanks. That's quite a broad-ranging question.
Well, we can cut it back to, I want to know why the targets that so explicitly listed to the policymakers in the main report didn't make it into the African fact sheets, neither the African one nor the Southern African one, because it's quite an important measure.
Right.
And will take significant effort. Thank you.
So that's quite a large question. Maybe one of the CLAs would like to take that on.
I think maybe Chris can comment. I mean, those targets are based on mainly on species range modeling at very large scales. But Chris, maybe you want to pick up one.
Yeah, so in the context of the African chapter, we didn't pull those targets through, partly because they are at the global scale. And as Guy said, based on global mapping of species ranges. And we didn't find, in the context of the climate risk, similar targets to assess for just the Africa-specific or sub-regional scales. But we do talk a lot about actions in protected areas and protected areas being a threat under climate risk. And so one risk that's identified in the report is that the existing African protected areas are, many of them are at risk of being degraded or disrupted because of linear infrastructure development, such as transport infrastructure or fencing, that is projected to have a severe risk of reducing the ability of many species to migrate to track shifting climates. So there's quite a lot of content in the Africa chapter around enabling climate resilience in protected areas, but you're right, we don't list those specific targets because they were seen as more global in nature.
But shouldn't we have at least listed the lower level of the target? Because internationally, everybody, especially for the aquatic resources, are moving away from the general 20% target to 30%. So we missed a bit of a trick not having it in the report. Thank you.
I think, Laura, the answer there is, as the IPCC, our job is to assess the evidence as opposed to set the targets. And so where targets are in the context of the policy, where they're mentioned in the policy context, we didn't repeat them, as our job is just to assess the underlying literature, not to actually report on the targets.
Thanks, Chris. I think we're going to have to draw to a close here. Guy, do you want to make an urgent point?
Just very quickly, I think we've got another trick up our sleeves, and that's the IPBES, Laura. The Intergovernmental Platform on Biodiversity Ecosystem Services is pushing those sorts of targets hard as well. So it's not only UNFCCC, but also IPBES in the CBD that's pushing it.
Okay, thanks, Guy. Like most of these discussions, there are more answers that we can even begin to get to and more discussions that we can begin to open. So we will try and capture all the written answers, and hopefully I can push all the panelists to collaborate on getting some responses out from this webinar to those, because there's a lot that needs to be discussed. I really want to thank all the speakers. This is really a timely development in the state of knowledge and in the global response to climate change. But I would like to make a point about this. We started off with 173 participants. Okay, that included a few hackers, but we had a really, really strong response to this webinar, and that I think is so indicative of the consciousness and awareness of the challenges that we face. However, the risks are diverse, they compound, they're significant. We have systemic inequity, and the challenges to taking action are non-trivial. And it's very easy to get somewhat depressed about the process. The science is not complete, but the science is clear. And so we have a knowledge base, which, while scary, also indicates that we can manage the risk. And so the question I would put back to you is not a case of can we do it? It's whether will we do it and how will we manage that? And for this, I'd like to close on just a few points here. That achieving a response based on the science that comes out of Working Group 2 and the IPCC in general is a response that comes down to the voices of the individuals who are making decisions. Those individuals who are informing decisions and those of us who are voting for the decision makers and enabling the decision makers. I would highlight Chris Lennard's point that Africa's voice is in a minority in the global scale. And there are many reasons for this, but some of them are that we just need to speak more loudly, or we need to be more engaged. And I remember Christiana Figueres, who was the Executive Secretary of the UNFCCC, at the Adaptation Conference, she made a challenging statement to the adaptation community. And she said, do not hide in the aggregate. And went on to talk about too many voices are hiding behind the collective cloud of people instead of speaking up. And so with that, I would like to end up posing you a couple of questions for yourself to answer. We will only achieve this as a collective. And so in a collective, we need to think about what is my unique responsibility in this? And each of us have a differentiated and personal responsibility. What is my unique role that I can engage with in facilitating a local, regional, and global response? And some people have different points of access. And what is my biggest challenge in achieving this? So that if I can articulate what the challenge is, I can put some resources against meeting that challenge. And there are changes happening. So within South Africa, for example, there's the development of trying to build a community of practice around this. There are new initiatives going on to try and enable a decision response and action response to the impacts and adaptation agenda. So with that, I'd leave you with those personal challenges for yourself to answer. Thanks again to ACDI and Stellenbosch to facilitating this webinar and putting it in place, and for all the speakers for their input. And I hope you go away with many questions that you challenge yourself with, and we can move forward collectively as a community on this.